Hi there, welcome back to our course on BDD with Cucumber and Serenity, and to Lesson 3, Writing Great Step Definitions. Previously, we saw how behavior-driven development allows us to use conversations and examples of behavior to understand how a system should function, and what the users need it to do for them. Cucumber lets us write these examples in the form of scenarios, in plain English, and then to use these scenarios to drive our automated tests. We saw how we write step definitions for these scenarios, for each of the steps inside the scenarios. Cucumber reads our scenarios and uses the text in the steps to figure out which method it should run. And we saw how Cucumber can even pass data, such as the distance from the shop, into the step definition. But we skimmed over some important details about how all this fits together. So in this lesson, we'll be looking at some of the finer points that you'll need to know about how to write really good step definitions. Let's start off with the basics. Each step definition method has an annotation: given, when, then. We've seen these in action in the previous lesson. There are actually two other keywords and two other annotations. Did you notice one of them in the previous example? The two other keywords are and but. We saw and in the first scenario. Sometimes you can make your expressions clearer and easier to read if you use and or maybe but. It makes these scenarios read more smoothly. For example, suppose we had another scenario. Buyer orders a coffee when they are far away from the coffee shop. We might say something like this: given Kathy is 5,000 meters away from the coffee shop, when Kathy orders a large cappuccino, then Barry should receive the order, but the order is not urgent. Using but isn't very common, but readability is king, and if you find that but makes your scenario more readable, then that's fine. You really want to use whatever combination of given, when, then, and but that reads best. Because here is the trick: Cucumber doesn't actually care what annotation you use. For Cucumber, they're all identical and interchangeable. We could say, given Kathy is 100 meters from the coffee shop, but we could also say, when Kathy is 100 meters from the coffee shop, or but Kathy is 100 meters from the coffee shop. All of these steps would match to the step definition method with the given annotation you can see down the bottom. Cucumber uses regular expressions to find the right step definition method to run, and also to find which bits of text should get passed into the step definition as parameters. You can see some examples of regular expressions here. Now, regular expressions can be a little bit scary, and the truth is, they can be used for both good and evil, so to speak. Regular expressions can be complex and hard to maintain, but in fact, when you write Cucumber step definitions, you only need a small number of relatively simple expressions. By the end of this lesson, you'll be comfortable using all of the expressions you can see here and more. But more importantly, you'll understand that in reality, you can get away with a small subset of these for most of your step definitions. So let's go through the main regular expressions that you will come across and that you will need to use in your own Cucumber step definitions. The first one is really simple. When you use some text as is, with no changes and no regular expression symbols, then it matches the text in the scenario. Here we have our annotation: given Kathy is 100 meters from the coffee shop. And the scenario text is: Kathy is 100 meters from the coffee shop. And this will match. Now, this might sound obvious, but there's a trick that you should be aware of. You see, if you provide a piece of text, Cucumber will match any scenario step that contains this bit of text anywhere in the step. So if we match the expression Kathy is 100 meters from, it will match Kathy is 100 meters from the coffee shop but it will also match Kathy is 100 meters from the supermarket. Sometimes this is the behavior that you want, but most times it isn't, and you most certainly need to be aware of how it works. Luckily, there's a workaround with a more intuitive behavior. The workaround is to use anchors. Anchors are the hat character you can see at the start of this expression here, and the $ at the end. Hat means that this expression will only match the text if the text is at the start of the step. And the $ means that where the expression ends, the step text must end too. So this expression will match Kathy is 100 meters from the coffee shop, but it won't match Kathy is 100 meters from the supermarket, and it won't match Kathy is 100 meters from the coffee shop in the city. So far we've been matching hard-coded text, but there's no fun in that. The beauty of Cucumber step definitions is the way we can pull out data from our steps and pass them into our tests. We've already seen this in action in the previous lesson, but let's take a closer look at how it all works. The simplest regular expression is .*, which matches any string of characters. We can see an example here. To match large cappuccino in when Kathy orders a large cappuccino, we use .*, which will match any order coming after when Kathy orders a. IntelliJ marks the text that will be passed into the step definitions in blue, like large cappuccino here. And we can click into the step definition by command clicking or control clicking on Windows into the method. If we break this down, the parentheses or round brackets mark out regular expressions in Cucumber. The dot represents any character, including spaces. The star is what we call a repetition modifier. Repetition modifiers tell Cucumber how many times a particular character can appear. In this case, star means any number of times, including 0. So .* means any character any number of times, including 0. In other words, anything or even nothing. This is probably the most common matcher that you'll see in real-world step definitions, as it covers maybe 70 or 80% of the situations that you typically need to deal with. The fact is, in many cases you don't need anything more sophisticated than that. You can keep things simple. But in some cases you do. Let's take a look at another example. As you can see, we've used .* again here to match the number of meters from the coffee shop. If we run this, Cucumber will parse the value and then pass an integer parameter to the step definition. Let's add some code to print the parameter output and see. If you look in the console output, you'll see the value 100 being printed out. So Cucumber is effectively analyzing the value 100 and passing it in as an integer. But what if we have a step like this? Given Kathy is 10 minutes late and 100 meters away. Notice how Cucumber has colored the whole block of text between 10 and 100. This means that the whole block of text, not just the distance value, will be passed through. And when we execute it, the test won't fail, because when you pass an integer in Java, it just ignores any text that follows the number, but it won't pick up the correct value either. So when we run the test again, you can see we're getting 10 rather than 100. The solution is to be a bit more specific than just to match any character. Rather than matching any character, we tell Cucumber to match only digits. Numerical digits are represented by the special symbol D. We need to use a backslash to show Cucumber that it is a special symbol. And we need to use another backslash because one backslash would be an escape character for Java, and that's not what we mean. So \\D matches a single digit. And, for example, 3 digits would be represented by 3 \\Ds. But of course, 3 digits won't work for 50 meters as there are only 2 digits, or for 1,000 meters. A more flexible approach would be to use the repetition modifier star that we saw earlier on. And \\d star does mean any number of digits, including no digits at all. But in this case, having no digits won't do. What we really need is a number with at least one digit. And we can do this with another repetition modifier. The plus symbol means at least one. So \\d plus means at least one digit. Let's go back over the regular expressions we've seen so far. Dot represents any character, and dot star represents any sequence of characters, including 0, including nothing at all. If we want a non-empty sequence of characters, we would say dot plus. D represents a digit, and in Java we say \d because we have to escape the symbols. If we want 0 or more digits, we'd say \d star, and if we want at least one digit, we'd say \d plus. There are two more symbols that you should know and that can be very useful in Cucumber. W matches any word character, any alphanumeric character or underscore, and S matches any blank character, so space, tab, new line, and so forth. We can also combine symbols to make more complicated expressions. Suppose we wanted decimal precision in our distances. Kathy is 100.25 meters from the coffee shop. Rather than matching a single sequence of digits, we would match a single sequence of digits, a decimal point. Now, a signal point represents any character, so we have to escape the signal point and make it \\, point for the decimal point, and then another sequence of characters. So here we have a sequence of characters, a decimal point, and another sequence of characters. And of course, we would need to convert our int to a float, so it actually parses the value correctly. We're not limited to a single parameter per step. Suppose we wanted to cater for Kathy and another user, Jane. We could say, given Jane is 100 meters from the coffee shop, we'll step into the step definition, and rather than passing Kathy as a hard-coded value, we make the name a parameter as well. And we add a parameter to cater for the user's name. And now we can have Kathy or Jane. So far, we've covered pretty much all you need to know about using regular expressions in matches in Cucumber. But we also use regular expressions for one other important thing, to make our scenarios more flexible and more readable. Suppose we have a scenario where Kathy is just 1 meter from the shop. What we'd like to write is, given Kathy is 1 meter from the coffee shop. But this doesn't work, because Cucumber is expecting meters in plural and not meter in singular. What do? Fortunately, there's a really easy fix. We can use the question mark modifier after the S, and what this does is it makes the S character optional. That way, the expression matches both meter and meters. We occasionally need to limit the possible values that we pass into a scenario to a specific set of values. For example, we might want to separate the size of the drink from the type of the drink, and we might want to limit the possible sizes to small, regular, and large. We could do this using the pipe symbol. The pipe symbol lets us give a list of possible values, like the ones you can see here. So in this case, only sizes of small, regular, and large will be accepted, and any other values won't be matched. Sometimes it's nice to phrase scenarios differently depending on their context. For example, if we are testing the order process, we might say, when Kathy orders a large cappuccino. But in a different scenario, for instance, delivery, where ordering has already happened, we might say something like, given Kathy has ordered a large cappuccino. We can do this by what's known as a non-capturing group. A non-capturing group is a regular expression that will not be passed into any parameters, but is just there to add more flexibility to the scenario text. Non-capturing groups start with ? For this example, we want to accept either orders or has ordered. Kathy orders a cappuccino or Kathy has ordered a cappuccino. And for this sort of thing, the pipe symbol that we saw previously works perfectly. We've certainly covered a lot of ground today, but you should by now have everything you need to know to write regular expressions for your own scenarios. Your step definitions will be more robust and more reliable, and you won't have to compromise on the readability of your scenarios. Because readability and communication are key in behavior-driven development. A Gherkin scenario is not a test script. It's a way of building a shared understanding with your stakeholders, so it is key to speak their language. That's all for today. I'm looking forward to seeing you in the next module. Until then, this is John Smart signing out.